this is going to be a lesson in what we call the unit circle. And this is really just a way to learn your basic trig values because you're going to use them so often. It's just like knowing your multiplication table. So we have certain values we just want to know, and they're just super important, and the unit circle is a way to remember them. Because straight memorization is okay, except if you forget. And then if you forget and you have no way to get it back, then you're kind of in trouble. So this is a way to remember it and use a tool to get them back if you're not sure what they are. So here I have two triangles, and this is just going to be a quick reminder because we're going to use these triangles. And here I've got one that we'll say is a 30, 60, 90. And this triangle is a 45, 45, 90. And those are the big ones that we're going to use in this circle. And here we're going to have the hypotenuse equal 1 on each of these. And that's because of the way the circle is going to be. It's going to have these triangles in it that have a hypotenuse of 1. So we've reviewed already how to find, and you had this in geometry, and then we've reviewed it, how to do the relationship on the sides on 30, 60, 90, and 45, 45, 90. So in a 30, 60, 90 triangle, we know that the short leg, which we know is the one opposite 30 degrees, is always half the length of the hypotenuse. So I let the hypotenuse length be 1, so therefore that side has to be a half. The long leg is always the square root of 3 times the short leg. So that's the square root of 3 times a half, which we write square root of 3 over 2. So that's the relationship that we're going to have in these triangles with a hypotenuse of 1. So for a 45, 45, 90 triangle, well, if you remember, if you took the short side in a 45, 45, 90, you were supposed to multiply it by the square root of 2 to get the hypotenuse. So we're going this direction. So we need to, instead of multiply by square root of 2, we need to divide by the square root of 2, which gives us 1 over the square root of 2 for this length, which of course means this one is the same. Now, it is typical to rationalize that and make it rationalize. That's just a normal way to say it. So 1 over the square root of 2 is what it is, but we rationalize it by multiplying by square root of 2 over square root of 2, and we get square root of 2 over 2. And so that's just long-standing been the way that we say this length, and so that's what we're going to use. So there's the relationships in our 30, 60, 90 and 45, 45, 90 when the hypotenuse is 1. So let's look at a circle. In this circle, I'm going to mark some things. Right now I have an angle marked in there, but in this circle that we have, this is called the unit circle, because the radius of this circle is 1, and that's super important. So this length right here is 1. The radius is 1. So this length is 1 because it's also a radius. Okay, now I'm going to get rid of that because I want to not leave that on there because we're going to draw some things on here. So what I've drawn on there is a 30-degree angle. So if I mark a spot right here where the 30 degrees meets the circle, and if I were to draw down a perpendicular to the axis, I would have a right triangle there that would be conveniently a 30, 60, 90 triangle. So, and I know the hypotenuse length here is 1. So in this triangle, you're going to have the short leg, which is up and down, is going to have a length of a half, and the long leg is going to be the square root of 3 over 2. We just went through that. So that's what you're going to have on this triangle. That means the coordinates of this point right here are, you go x first, so square root of 3 over 2, comma, 1/2. Well, also, if we look at this triangle and we do our trig functions, we will notice that if we were to find the cosine of 30 degrees, to find the cosine of 30 degrees, you would take, and this is our 30-degree angle, you would take adjacent over hypotenuse. Well, the hypotenuse is 1. So therefore, it's just going to be adjacent, and that happens to be this value right here. If you take sine of 30 degrees in this triangle, you're going to take opposite, which is 1/2, over hypotenuse, which is 1 again. So therefore, that's going to be sine of 30 degrees. So basically, that coordinate right there represents cosine of 30 degrees and sine of 30 degrees. Now, even though I'm starting off with degrees, this is actually not the easiest way to remember it. It's actually going to be really super easy if I remember this unit circle using radians. So we're going to switch it to radians here in just a minute. But right now, hopefully you can see where those coordinates came from. That's the coordinates of where that 30-degree angle intersects. Now, I'm going to erase these markings for this triangle, and I'm going to actually make a 60-degree angle now. So I'm going to get rid of my 30, and I'm going to make a 60-degree angle. So put my protractor here. Let's make it a little bit bigger so I can get 60 right up there, and I just mark that 60 degrees, shrink this, and then here's my 60-degree angle. So here's a 60-degree angle. And we're going to do the same thing we just did. So we're going to put a dot right here, and we're going to drop this line down and draw a perpendicular. And guess what? I have another right triangle that's also a 30, 60, 90. The difference is the 60 degree is the central angle there, the angle that goes to the center. But the hypotenuse is still 1, the short side is still a 1/2, and the long side is still square root of 3 over 2. That did not change. I simply kind of think of turning the circle on its different side, but the relationship is still the same. So that means the coordinates right here would be 1/2, because that would be the x direction, and then the height to go up to that point would be square root of 3 over 2. Oh, and I didn't leave my mark here. I guess I got rid of too many things. So there was my coordinates there for my 30-degree angle. Well, same thing's going to be true here. This measurement is going to be cosine of 60 degrees, and this measurement is going to be sine of 60 degrees. So if I'm working a problem and I need to know what is the cosine of 60 degrees, I can actually think through this triangle a little bit, this unit circle, and figure out that answer. And I'll show you that and make more sense of that when we get it all kind of put together. Now, instead of saying 60 degrees and 30 degrees, though, I actually want to use radian measures. So let me get rid of this again and get rid of my angle. We see where that came from now, hopefully. And instead of 60 degrees and 30 degrees, I want to think in radians. So if you look carefully, you should be able to see that basically if I were to continue to mark in the similar manner around the circle, I would have divided the top half of this circle into 6 equal little wedges. Well, those 6 wedges, if I go halfway across, remember that's pi. Half a circle's pi, all the way around, well, this is also 0, but it's 2 pi. So all the way around, 1 revolution is 2 pi in radians. So halfway around is pi. So that means if I've divided it into 6 equal parts, that this first coordinate must be, this angle must be pi over 6 in radians. And that means this must be 2 pi over 6, but 2 pi over 6 simplifies to pi over 3. And I can continue to count like that all the way around the circle. If I get to the next one, I would have 3 pi over 6. But 3 pi over 6 simplifies to pi over 2, which makes sense because that's half of the top of the circle, so that's pi over 2. This would be 4 pi over 6, but 4 pi over 6 would simplify to 2 pi over 3. This is 5 pi over 6. This would be 6 pi over 6, which again, of course, simplifies to pi. So we can use those radian measures to help us remember some things. So I'm going to take off the ones where I was counting and just leave where we simplified it, because we always want the simplified measures and not those. But that's a quick way that you can count that out to get around the circle and figure out where you are. So we have pi over 6, we have pi over 3, pi over 2, 2 pi over 3, 5 pi over 6. Okay, well, let's figure out real quickly what the coordinates would be at pi over 2. This is a unit circle, which means the radius is 1. So the coordinates here would be clearly x would be 0 and y would be 1. And then let's go ahead and go over to pi and do the same thing. Well, pi would be negative 1, 0, because again, a unit circle. Now, let's notice here, and on your paper, your drawings kind of have this drawn here because we're answering these values. Okay, so let's notice something. If I drop that triangle down from pi over 6 and get my 30, 60, 90, do you notice that at 5 pi over 6, you should see you're going to get the exact same thing. It's just on the other side, but the triangle is going to have the same measurements. It's going to have everything the same. The only difference is going to be at 5 pi over 6, x is negative. So you'll have negative square root of 3 over 2, comma, a half. If I do something similar at pi over 3 and I drop this down and make a right triangle, well, if I do it at 2 pi over 3, I get the same triangle. I just get it reversed, flipped, but it's going to have the exact same numbers. The sides will be the same. This is still a half long and this is still square root of 3 over 2. The difference is coordinate wise, it's negative 1/2, negative square root of 3 over 2. Now, let's continue on around the circle and notice some things that are going to happen. So let's go ahead and count off on the bottom by 6's too. So let's divide it into 6 equal parts again, as close as we can. And then let's keep counting. So we had 5 pi over 6, then pi was 6 pi over 6, so that would make this one 7 pi over 6. The next one would be 8 pi over 6, but 8 pi over 6 would simplify to 4 pi over 3 if you reduce the fraction. Then you would have 9 pi over 6 right here on the bottom, but 9 pi over 6 would simplify to 3 pi over 2. Then you would have 10 pi over 6, but 10 pi over 6 would be 5 pi over 3. Then you would have 11 pi over 6, and then you would have 12 pi over 6, which of course becomes 2 pi. Well, the reason we want to leave these simplified is watch what's going to happen here. So let's do what we just did again. Let's go to 7 pi over 6, and let's draw that in a little bit more like where it really is here. And let's draw that again. Let's draw this triangle. And guess what? You get the same triangle you got at 5 pi over 6, which is the same one you got at pi over 6. The only difference is here your coordinates, your lengths are the same. This is still square root of 3 over 2, and this is still 1/2. But in your coordinates, you would have negative square root of 3 over 2, negative 1/2 if we're in our coordinate system. If we go over to 11 pi over 6, again, notice the same thing, same triangle. So any pi over 6 has the same exact triangle. The only difference in the coordinates are what quadrant you're in. So this is square root of 3 over 2 and then negative 1/2. Notice the same thing's going to happen at your pi over 3. So if you go to your 5 pi over 3, which really should be over here a little bit, let's mark it where it's really supposed to be. There's your 5 pi over 3. Then we make our triangle. Just like we did above, we get the same triangle we had above. And if we do it to 4 pi over 3, it's same thing. You're going to have this triangle. It's exactly identical to the ones above. The only difference is your coordinates are the signs of them. So this is going to be positive 1/2, negative square root of 3 over 2, and this is going to be negative 1/2, negative square root of 3 over 2. So what we notice is that at every pi over 3, you have the same two coordinates. You just don't have, oh, and I think I wrote negative up there. That's just negative 1/2, positive square root of 3 over 2 there. I don't know if I wrote negative or it just, I did my line weird, but that's, make sure you have that one right. So that's up here at 2 pi over 3, it's negative 1/2, positive square root of 3 over 2. But every time the coordinates are basically your 1/2 square root of 3 over 2. All you need to do is know what quadrant you're in to change the SIG in for that. Then what we notice is cosine of 60 degrees is 1/2. Well, let's think cosine pi over 3 then instead. And then let's think here sine of pi over 3. And that's what we're going to use to learn those measurements. So we're going to go into more of this later, but what I'm trying to get you to see now are the patterns that are here. So what we basically figure out from this is I actually really only have to know this measurement and this measurement and know that anything that's at a pi over 6 or a pi over 3 has the same two basic coordinates, and then it's just a matter of what quadrant are they in to know whether x is positive or negative or what sign we have. So that's the 30, 60, 90s. Let's do very quickly a similar thing with 45, 45, 90. So now let's take the top half of the circle and let's divide it into 4 equal parts. So you're going to have halfway, 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 and we'll do the same thing on the bottom. So we're going to divide this up. So we'll go a little quicker this time because it's the same basic idea. So if pi is halfway across the top of the circle, this must be pi over 4. Up here would be 2 pi over 4, but again, it would simplify to pi over 2. We already know those coordinates, but that would make this 3 pi over 4, and then pi would be 4 pi over 4, which of course simplifies to pi, so we don't necessarily need to write that. Now let's do the same thing. Let's draw a triangle down here, and notice you're going to have a 45, 45, 90 triangle, because I split 90 degrees exactly in half. Hypotenuse is 1. We just learned this, so that means this is square root of 2 over 2, and this is square root of 2 over 2, which means your coordinates are square root of 2 over 2, square root of 2 over 2. Well, guess what? You're going to get the same triangle over here that you got over there, so you're going to get negative square root of 2 over 2, square root of 2 over 2 for the coordinates. You're going to get the same exact triangle here, and the same exact triangle there. So your coordinates here, which would be 5 pi over 4, because we were just at 4 pi over 4. These coordinates are negative square root of 2 over 2, negative square root of 2 over 2. And then you would have 6 pi over 4 down here in the middle, and then your next one here would be 7 pi over 4. And your last would be 8 pi over 4, which of course is 2 pi. So here we're going to have, again, coordinates, same numbers, just here it's positive square root of 2 over 2, negative for y, because we're in quadrant 4. So again, same thing. Really, I only have to know this value, and then it matches everything else. And this happens to be cosine of pi over 4, and this happens to be sine of pi over 4. So that's just a way we can memorize things. So to fill in our entire circle, I'm going to fill in part of it, and then we're going to fill in the rest in class so that we can talk about what we learned here. So we know this was 30 degrees, and we called it pi over 6. And the coordinates here, well, this was the long leg, and then short was up and down. So short was a half, and long was square root of 3 over 2. It's really hard to write that small. Square root of 3 over 2, 1/2. There we go. Whoop. All right, and then the next one was 45 degrees, which was pi over 4. And you had square root of 2 over 2, square root of 2 over 2. And then we had 60 degrees, which was pi over 3. And we had, this time, it was a little bit, the short side went horizontally, so that's our x, and the long side went up and down, square root of 3 over 2. Up here we have 90 degrees, which is pi over 2. And of course our coordinates, it's a unit circle, so x is 0 if I'm on the y-axis, and y would be 1. And then we can continue around the circle to do the same thing, but we're actually going to, I want you to see if you can fill that out. I'll put a few of them down and see if you can figure it out. Do it in pencil, of course, and then we'll finish it in class. So this would be 2 pi over 3. This would be 3 pi over 4, and this would be 5 pi over 6. You'll get better at counting those out, but you just have to think about splitting the circle up. And easiest to count by pi over 6s, really. So your coordinates for 2 pi over 3 are just negative 1/2 square root of 3 over 2, because they're the same as the pi over 3, except your x is negative over here, and then you'll have negative square root of 2 over 2, square root of 2 over 2, and then you'll have negative square root of 3 over 2, positive 1/2, because again, you're at a pi over 6, just like this one. So you can go ahead and fill in more of that, but we will finish that in class. And so that's it for this video for the unit circle, and we will do more in class.